Hey everybody, Bill Sky, the COBOL guy, and it's been a little while, but what we're going to do today is we're going to continue our discussion of functions. Now, if you took a look at the previous video, I think it was 13A, Introduction to Functions in COBOL, that I did, those aren't really functions. Those are just procedures that are inside of a main program. Very, very useful. I've used them many, many times. However, they're not really functions. And what do I mean by that? A real function has its own memory area. It has its own internal variables. You send it data via variables. You return the data from the function to the calling program or procedure from the function. And those all have to be put into the linkage section. And we're going to talk about all that. But see, that's the difference. You don't have any of that in normal procedures. Normal procedures are just global. They have global access to all variables in the main program, so it's not strictly a function. It's more of a procedure. So we're going to talk about two things. We're going to talk about subprograms and we're going to talk about functions. They're very, very similar. Now, we're going to be using GNUCobol here just because of the ability to get to it very easily. However, every compiler does it a little bit differently. For instance, on IBM COBOL, you have to run all of this through JCL, Job Control Language. You have to compile the object library which contains the function, which we're going to do in a coming video. We're not going to actually do it on an IBM mainframe, but we're going to do it on GNUCobol. So it's all different. Fujitsu COBOL, Microfocus COBOL, all of them do it a little bit differently. So can I show you all of them? Not really, but I can point you to all of the documentation that you need. Now, this is normal for legacy languages, especially when they come from different manufacturers because they do things a little bit differently. But for mainframe, you really have to take a look at the IBM ZOS mainframe tutorials that you can get. And if you take a look at my Bill Sky, the Mainframe Guy playlist, you can see how to get started with that. And once you get started, you can, after the first couple of lessons, you can just go ahead and do it yourself. You can go ahead and complete the IBM tutorials yourself. So anyway, so let's do this on GNUCobol, and then we'll talk about the differences and things like that with IBM mainframe. Okay, so I'm going to go ahead and I'm just going to create a new COBOL project, and I'm going to call this one subprograms, and you'll see why I call that in just a little while. And then I'm going to go ahead and open up the source code. Now, a subprogram is different from a main program. Well, actually, it's not really different. It has a different name. And we're going to go ahead and actually create that. And what I'm going to do is I'm going to go down to the bottom of my source code. So after the main program, and I'm going to create a new program. Now what I'm going to do is I'm going to copy, and let's just do this simply. I'm going to copy everything from my main program down here, and I'm going to give it a different name. In this case, what do I want to call it? I'm going to call it, well, let's play around with some trigonometry. Let's play around with some intrinsic functions in COBOL. So what I'm going to do is I'm going to call this one degrees to radians. Now, the functions, the trigonometric functions that are intrinsic to IBM COBOL, I shouldn't say that, GNUCobol, they require radians. I'm not really sure. I don't remember on mainframe COBOL, IBM COBOL if they do. I believe they do. But they require radians. So what we're going to do is I want to be able to have the user type in degrees, and then I want to convert that into radians. So what I did here was I just copied the entire identification division. I left out some of these comments right here. But I copied the entire environment division, identification division, the entire thing, the entire program, down here underneath the main program, and I renamed it. I said degrees to radians, and I'm going to do that on the end program as well, end program degree to radians. Okay, now I'm going to want to go ahead and modify a bunch of this stuff. I want to make sure I put in the right information. The other thing I need to do is if I'm going to be accessing the intrinsic functions, if I'm going to be accessing the intrinsic functions of the COBOL compiler, in this case GNUCobol, I have to go down here to the object computer, and I have to say I'm going to say here repository, and then I'm going to say function all intrinsic. And that will get me access to all of the intrinsic functions in COBOL. Now I'm going to copy those down here as well. And I'm going to go ahead and renumber my code. Reload it. And this I'm using Genie. Oh, it looks like I've got some, let's go ahead and reload it. Yeah, I've got a little bit of issues here. Let's go ahead and try that again. Renumber. Okay, it looks like I got a problem with my makefile. I need to go update that. So I'm going to get rid of .r. I'm not really sure what's going on there. So let's go ahead and update my makefile. Okay, so it depends upon the Linux you're using. awk doesn't have that -i in place. However, gawk does. Now, again, if you're on, I believe if you're on Ubuntu Linux doing this, the awk works. Now, what is this whole awk thing? I added a thing to my makefile that allows me to renumber my code, and that's using gawk or awk. Now, the other thing you have to worry about is white spaces. So if you're going to do this, you need to make sure that you get rid of all of your white spaces. And I believe, yeah, let's get rid of all of those. So I just put spaces in there. Again, my editor, I don't have my editor set up just right, just to put in spaces. It puts in actual tabs. So I can fix that later on. So I'm going to go up here and build and make custom object renumber. And I'm going to reload it. And then we can see our repository function all intrinsic. Everything is there and we have nice numbers. Okay, so let's go ahead and make it. And it ran just fine. Now, again, this is a subprogram down here. So that's what we call a subprogram. It is a program within another program's source code or even outside of it, but it has this program ID thing there. It has that feature. Now, for functions, you would say function ID, but if for in this case, we're going to say program ID because it is a sub-program. It is a program that actually could probably run on its own. However, we're just going to have a function in there. It's just going to have a single thing. Okay, so the next thing we need to do is that we need to create a number of variables up here on top on the main. So let's go ahead and do that. I'm going to go ahead and, now before I do that, well, yeah, so I'm going to go ahead and add some variables here. So let's go down to the working storage section, and I don't really need this counter here, so let's get rid of that. And I'm going to say, let's just create some 77s. And I'm just going to say usage is comp1 value 0. And then I'm going to create some more. Let's create a second one. I would like to display a fraction correctly, so I'm just going to say display frac. I'm going to make it a pic_z 9.94. Here we go. So that'll be for the display. Okay. Now, the other thing we're going to do is we're going to create some variables that are going to be used to talk to the subprogram. So I'm going to say 70 radians bar, and I'm going to say usage comp1. I'm going to say degrees amount, and let's make this capital R just to kind of keep our naming convention the same. Usage is comp1. Now, one thing about comp1, comp2, all of those different binary representations of data, GNUCobol requires, from when I originally wrote this tutorial, GNUCobol would only pass comp1s back and forth, numerics. So, but every COBOL compiler is a little bit different, as I mentioned in the introduction. So you're going to want to take a look at how you're going to send data to a function or to a subprogram, depending upon your compiler that you're using. Okay, So that's it. So those are our variables. Let me go ahead and build that, make sure I don't have any issues. Everything looks good. Okay, so now let's go into our procedure division, and we're going to say hello world, welcome to functions and subprograms. Okay, and let's actually start doing some coding here. So I'm going to say move 90 to degrees amount. And I'm going to display something. So I'm going to say display before degree to rad call degree amount equal, just so I can do a little bit of debugging here. Okay, let's go ahead and save and build that. And what I want to do now is I want to run it. So I'm going to run it from the terminal. And I guess I could do it from here, from the GNI terminal. So let's set path from document. And it's looking good. So we've got our 90 in there. Hello world. Okay, things are looking up. All right. Now let's go ahead and now call our function degree to rad. Now the way that you do that in COBOL is I'll say call, single quote, degree to rad. That's the subprogram, using degrees amount and radians variable. So what we've done here is that we've said that we want to call the subprogram degree to rad, and we're going to use two variables. We're going to use degrees amount and radians var. And we're simply telling the compiler those are the two variables that we want those two to share. So let's go ahead and make that. It still is okay. Now our function really doesn't do anything with that at all. So let's go ahead and put another display after degree to rad call radians var equals. Okay. Let's go ahead and build that. Let's go ahead and run it just to see how things look. We've got this, we've got this, and we've got the hello world. That is from our function, our subprogram down here. Again, I'm going to say function now and again, and I don't mean to be doing that. In this case, this is a subprogram. So what we're going to do is we're going to get rid of this hello world. Now if you notice the stop run, it actually stopped the program. It actually stopped the actual entire program. So we're going to need to return that. Now how do I know it stopped it? Because I didn't print off after degree to rad call. If you remember in my code, I had a new display up here. So it did this because we got the hello world, but it didn't display this. So the program actually stopped running. So we've got a problem there. We don't want the program to stop running using the stop run. We want to use actually what we call the go back, and we want to return something. I'm going to say go back returning. We have a variable we need to return because that's what our function is going to do. It's going to take degrees, it's going to convert it to radians, and it's going to return it. So how do we do that? How do we actually do that? So what I'm going to do is up here in the linkage section, and that's right below the working storage section. There it is. Oh, I don't have it in my template, so I'm going to add it. I'm going to say linkage section. I'm going to add some new variables. So I'm going to say degrees value, and I'm going to say usage is comp1, and I'm going to say rad value I'm going to say usage is comp1, and so we're going to be returning rad value. So I'm going to say go back returning rad value. Now as a reminder, when you get the degrees, you got to do a little bit of a calculation, and then you have to return the value. You have to, after you convert it from degrees to radians, you have to return the value. So we haven't done anything there. So let's go ahead and see if this go back fixed our problem of the entire program ending. Now it looks like we have a problem here. I think it's probably a period problem. Oh, I think I put my linkage. I think I put my linkage section somewhere wrong. Let's see. Oh, it's because I've got these other things. So I'm going to move my linkage section. So I'm going to move that right before the procedure division. And the linkage section is part of the data division. Okay, let's see if that fixed the problem. Yep, that fixed the problem. Let's go ahead and renumber it. And let's reload it. There we go. Okay, so let's go ahead and run it. Oh, okay, so we haven't really, okay, it seems to have worked a little bit better. In other words, the subprogram is actually working as a subprogram, but the problem is that rad value has a null value. So we actually have to do some more coding here before we actually get this working. Okay. All right, so let's go ahead and do our calculation, and let's see if that fixes that problem. So I'm just going to simply say compute rad value equals degree value times pi. Now pi is a GNUCobol constant. It may be different for whatever other compiler that you're using. I'm going to divide by 180.0. Okay, that's all we're going to do. I'm just going to divide it by 180, and that is the equation. Let's go ahead and make it. Oh, yep, I didn't put my specifiers. Let's go ahead and... Okay, so it looks like I've got other problems here. I've got some naming issues. Let's go ahead and make this degrees value. There we go. Finally it worked. Now, let's go ahead and run this. Oh, things are looking a lot better. Okay. So, what happened? In my main procedure division, I'm printing hello world, welcome to functions and subprograms. I then move some data into that degrees value variable, and I display it. Degrees amount is 90. I then call the subprogram deg to rad, and I then do the conversion. I take the value that's sent to it, which is degrees value. I multiply that by pi, divide it by 180, put that into rad value, and then I go back to the calling program, returning that rad value that I just computed. Now, one thing I love to do in my programs is display a goodbye. So I'm going to say display program ending. And the reason I do that, especially when I'm debugging a program, is I like to see that the program actually made it to the end of the code. And it did. So the program ended, and that's where we got our stop run. Whew. So that's a subprogram. And a function is basically the same way, except you call it differently. So let's go ahead and renumber this. Reload it. Okay. All right, so that's a subprogram. We specify in the linkage section of the subprogram, we specify what the data is that I'm going to be using to communicate between the subprogram and the main program. We tell the procedure division that you're using going to be using degrees value and rad value. Rad value is going to be returned, degrees value is going to be supplied, and then I do the compute, and then I do the go back returning that rad value. And it seemed to work. We actually got a good response, or a good result from that. Okay. Now that's a subprogram. Now this is it's not really an inline subprogram, but it's a subprogram that's part of the same source code as the main program. And in the following video from this video, I'm going to show you how to put those into separate object libraries and then use them by multiple programs. But in this case, we're just going to do it inline until you get used to it. Okay, so the next thing I want to do is I want to talk about actual functions. Now, what is how do you call an actual function in COBOL? It is a lot more like C, C++, and Java. And let me actually show you this. So I'm going to go up to now I'm in my main code here. I'm going to do this. I'm going to say radians var equals, I have to say compute, equals degree to rad, and then we send it an argument inside the parentheses, in this case degrees amount. So it looks a lot alike. It looks a lot the same as other languages calling functions. The only difference is that you say compute, not computer, but you say compute in COBOL to specify that you're actually doing a function, kind of like you would do in Fortran or other languages. Okay? Well, let's see if that builds. Now, it's not going to build because we also have to tell our main program that there's a function coming up. So we have to kind of prototype it. So under functions intrinsic, I'm going to say that there's a new function called degree to rad. And let's actually create a new function. We're not going to do a subprogram. We're going to do a new function. So I'm going to call it degree to rad f. Now I still don't believe it'll build because we actually haven't created that function yet. So let's go ahead and take a look at, have to get rid of this period, I believe. So let's go ahead and now create that function. So we're looking for degree to rad f. And that will be down here in our call, degree to rad f. And again, I don't think this will build. Oh, it built. I don't think it'll run because we actually haven't done that. Yeah, it could not find degree to rad f when we ran the program. All right, so let's go ahead and create degree to rad f. And the way that I'm going to do that, I was going to simply copy my subprogram. So I copied my subprogram degree to rad, and I'm going to put an F now here. And instead of program ID, I'm going to say function ID. And down here below here, we have to say degree to rad F. Instead of program, we have to say function. Lot of rules here. So there's a couple of other things that we have to do. In a function, you specify in the procedure division, it's using degree value, but it's going to returning rad value. There we go. So that's really the differences. So let's go over what I changed here. So what I did was I copied my subprogram. I changed it from program ID to function ID. I changed the name of the function or the name of the subprogram to degree deg to rad f. I just simply added the f at the end. My linkage section is the same. I had to change the procedure division to say using, but then also returning rad value. And then at the end, I said end function instead of end program. Okay, let's see if that works. So I'm going to copy my display after deg to rad f call. Let's renumber it. Let's build it, and let's see if it'll run. Okay, so let's take a look. We start our main program with the hello world. We print the degree to rad call. So what is before we did that, what was the value of our degrees? It was 90. After the degree to rad call, our radians variable was 1.5707964. And then we went ahead and just called it again using the degrees amount of 90. But we didn't call we didn't call the subprogram, we called this the function, degree to rad f. And there you go. Now what can we do with some of that? Well, let's play around with this. Let's do some coding here. So I'm going to say move the sign of radians var to display fract, and then I'm going to say, I don't know, compute display fract rounded equals the sign of radians var. So why am I doing that? Because there's different ways of displaying that data. Let's do that. Let's go ahead and say display sign of radians var without rounding equals, and we'll say display fract with rounding. And this is in our main procedure division. All right, looks different. All right, cool. So we've got our radians. We converted our degrees into radians using our function and or our subprogram. And we went ahead and got that radians value. We did the sign without rounding, and we did the sign with rounding, and we get a 1.0, which is the sine of 90 degrees. So that's pretty neat. Let me go ahead and renumber this so I have a final program. Okay. So we did a subprogram, we did a function. They are a little bit different. Functions, and mainly the main difference for when you use them is the way you call them. So a subprogram is called using the call verb. The function can be executed using this syntax where you say the function name parentheses and your arguments. Okay, so that's an introduction to a subprogram. That's an introduction to a function, a real function in COBOL. The next video, we're going to talk about separating those out into separate source files. Again, we're going to be using GNUCobol, so it'll be different on every other COBOL compiler that's out there, especially IBM COBOL, because that's mainframe COBOL, and you pretty much do everything there with JCL. You get all that set up with JCL. But until then, keep on coding in COBOL.